sets, matrices, propositional logic, and probabilities. So we're going to start with filling in the blanks. Then we're going to proceed to some calculations and drawing or elaborations and or discussions. The first one is a measure of uncertainty. It shows the likelihood of an event occurring or happening. So the answer here is probability. And we all know that probability is from 0 to 1, or from 0% to 100%, multiplying this by 100. So there is no negative. We don't have values which are negatives. And we don't have values after 1 or after 100%. So the lowest is 0% or 0. We call this as an impossible event. 100% or 1 is called a sure or certain event. So we are very certain that that particular event is going to happen. An example of a certain event is a class that has 25 students and all the students are girls. So the probability of getting a girl if a student is selected is 100% because all the students are girls. And P of boy will be 0, impossible, because the class contains students which are all girls. Okay, so it happens in real life scenarios. We have impossible event and we have sure or certain event. But these events are rare. In most cases, we have between 0% to 100% exclusive. For example, 5%, 85%, okay? So it will never go beyond 100% or below 0%. Other definitions that you need to know are the following. Propositional logic, which is a branch of mathematics that studies the logical relationships between propositions. It is also a branch of logic, okay? A branch of mathematics dealing with logical relationships between propositions, or we call this as statements or sentences or assertions, taken as a whole and connected via logical connectives, or we call this as logical operators. The most common logical operators are or, and, not, exclusive or, if then, and if and only if. So these are the most common logical operators. We have more operators, but those are not very common, okay? These are the most common ones. The next concept is about number system, a writing system used to express numbers using digits or symbols in a consistent manner. Okay, it is consistent because every digit has a place value. A matrix is a rectangular array of numbers with S, okay, variables, or any objects given in rows and columns. Right, so these are the topics we have discussed already in our classes. Now here, given below are matrices where A is equal to B, and you're asked to find the value of M. So what we're going to do is to equate the elements because A is equal to B. So negative 69 is equal to negative 69. Okay, M minus 1 over 3 is equal to 1 over 6. And 222 is equal to 222 or 222. Now to find the value of M, we have to equate M minus 1 over 3 equals 1 over 6. So what we're going to do is to basically cross multiply. So m minus 1 times 6 equals 3 times 1. Okay, so m minus 1 times 6, and here we have 3 times 1. So this is 6 times m, 6m, and 6 times negative 1, negative 6 equals 3 times 1 is equal to 3. And 6m equals 3 plus 6. We transfer negative 6 or minus 6 to the other side. It becomes plus 6. So 6m equals 9. Then we divide both sides by 6. So this is cancelled. M is equal to 9 over 6, or 3 over 2, or 1.5. Okay, so that is the value of our M. Let's proceed to the next exercise, number 3. Here, there are two outcomes when a coin is tossed, because there are two sides. We have a head or a tail. The question is, what is the chance percentage of getting exactly 2 tails if the coin is tossed 2 times? Okay, so during the first toss, okay, there are 2 possibilities. H is head and T equals tail. Okay, so there are 2 possibilities, a head or a tail. Now, if it was head on the first, it could be head or tail on the second. If it was tail on the first, it could be a head or a tail on the second. So this is the second toss. So we follow line by line. The first possibility is HH. It means that head on the first and head on the second. Second one is HT. Third one is TH. And we have TT. So these are the possible outcomes. We have 4 possible outcomes: head on the first, head on the second, head on the first or tail on the second, tail on the first, head on the second, or both tails. The question is, what is the chance percentage of getting exactly 2 tails? So there is only one possible outcome. So that is 1 over 4. Because we have 4 possible outcomes, okay, equals 0.25 or 25%. Okay, so there is only one possible outcome to get exactly 2 tails. So 1 over 4, it's 25%. Okay, let's go to number 4. What is the simplified form of the quantity of B complement intersection A complement? When I say quantity of, I'm talking about a whole group. Okay, so the quantity of B complement intersection A complement raised to the power complement, we're going to use the Morgan's law and laws of complements. Okay, complement properties or complement laws. So basically, what happens here is that we distribute. So we have one complement inside and outside. So this will become 2 complements. An intersection becomes union. And this is A complement complement. Okay. So B complement is B. Union A complement is A. So please take note, if we have double complements, it will be cancelled. A complement is A. So this is the final answer, B union A. And using the Morgan's law, if we have a complement outside, the operation inside will be reversed. So if it is an intersection, it's going to be a union. If it was union, it's going to be intersection. Okay. Number 5, group of objects given in a well-defined manner. So this is set. Okay. We can use set builder notation, roster method, or the listing method, or we can use a description. Number 6 is using absorption law. The answer here is W. If we have a set outside, repeated inside, and the operation is reverse, it's going to be observed. This one is going to be observed by the first set. Okay, so if you have A intersection A union B, the answer will be A. If you have A union A intersection B, it's gonna be A as well. Okay, it's going to be absorbed by A. Right, so I hope that's very clear. Let's go to number 7. P or not P is equivalent to tautology. Okay, it's like A union not A equals universe. Okay, so tautology actually is equivalent to universal set in set theory. We can also prove this using a truth table. Here we have only one proposition, that is P, because this is a logical operator or, and this is also a logical operator not. This is inclusive or. Okay, so there is only one sentence there, one proposition, P, which could be any sentence or any proposition. It could be 1 is greater than 0. It could be mascot is part of woman, any sentence. So our truth table could be like this. There are only two possibilities because we have one proposition. And not P, opposite of P, not true is false, not false is true. And the whole proposition P or not P, okay, we have true or false is true, false or true is also true. As you can see, we have double T here, all true, so it is a tautology. All right, so here we're going to convert 75 base 8 to base 16. I hope number 7 is clear. P or not P is a tautology. Here, the first thing you're going to do is to convert to base 2 first. Okay, so we have 7 is equal to 421 and 5 is equal to 421 because 4 plus 2 plus 1 equals 7, the highest digit in base 8. Okay, base 8 we have 0, 1, 2, 3, 4, 5, 6, 7. This is octal number system. The highest is 7, so we have 4 plus 2 plus 1 equals 7. That is coming from here. Okay? So 7 is equal to 4 plus 2 plus 1, so all of this will be on. 1, 1, 1, okay? 1 is on, 0 is off. Here, we need to get 5. So all we need are 4 and 1 only, because 4 plus 1 equals 5. So this is off. Okay, we don't need 2. So the answer is 1, 1, 1, 1, 0, 1, base 2. But we need to convert to base 16. So this is only the first step. The second step is to convert this base 2 to base 16. So what we're going to do is to use 8421. Because 8 plus 4 plus 2 plus 1 equals 15, or F, the highest digit in base 16. So we have 4 digits, 8, 4, 2, 1. So we need 4 digits from right to left, 1, 2, 3, 4. This is the first group. And we write 8, 4, 2, 1 below the digits. Okay. So for the next group, there are only 2 digits. We have to add 2 more zeros to make it 4. Okay. So that's it. And we're going to assign 8421 below the digits. So we are not going to count this. We're going to count only 2 and 1. That is 3. 2 plus 1 equals 3. Here we're going to count 8, 4, and 1. We will not be including 2 because it has 0 above. So we have 8 plus 4 plus 1 equals 13, or D. Okay? So please memorize. We have A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, F equals 15. Okay? So our D is 13. So the final answer is actually 3D, because our 13 is D. Okay? All right. By mistake, I erased all the answers here. Here we have tautology. Here the answer is 3D. I want you to, watch the video, try to forward or rewind, pause for you to master these concepts. Okay, so again here, we start with 7, 4, 2, 1, so 1, 1, 1. 5 is equal to 4 plus 1. So we have 1, 0, 1. So this 1, 1, 1, 0, 1 base 2. And then we change to base 16, 4 digits, 8, 4, 2, 1. We add 2 zeros here, 8, 4, 2, 1. So we have 3 and 13. 3, 13 is 3D base 16. So A is 10, B is 11, C is 12, D is 13, E equals 14, and F equals 15. The highest in the hexadecimal number system. That is why we use 8, 4, 2, 1, because 8 plus 4 plus 2 plus 1 equals 15, or F. Okay, so here we're going to convert 1, 2, 3 base 8 to base 10. 10 is on the right. So we're going to use the multiplication and addition. Actually, the formula is D times 8 raised to the power of n. Okay, this is for octal, because here we have an octal number. Of course, for binary, you will use D times 2 raised to the power of n. For hexadecimal, you're going to use D times 16 raised to the power of n. So here, our first D, so we assign the exponents from 0 to infinity. Our first D is 1, this. So 1 times 8 raised to the power of 2, plus the second is 2. And the last is 3, 8, 0. So the answer is 83. Okay? I want you to try this. It's base 16 going to base 10. Okay? Using the same method. Here, you're going to use this formula, D times 16 raised to the power of n. So you're going to start with 0 here, 1, 2, 3. Okay. So D is 13, C is 12, E is 14. So you have to multiply and add like this. Okay, that is your homework. Let's proceed to number 10. Here is the opposite of number 9. Number 9, our 10 is on the right, base 10. Here, our 10 is on the left. Okay, If 10 is on the left, you're going to use a table. If 10 is on the right, you're going to use these formulas. Okay. So we are going to put 33 in the middle. Then we divide by whatever is the number on the right. Okay. If this was 8, you have to put 8 here. If this was 16, you have to put 16 here. 33 divided by 2 is 16.5. But we write only the whole number. 33, we have to bring it down. Minus, this is always minus. Multiply this 2. 2 times 16 is 32, so the remainder is 1. RE here is remainder. The remaining. Now 16 by 2 again is 8. 16 minus 2 times 8 equals 0. And we divide by 2 again is 4. 8 minus 2 times 4 equals 0. Then we have by 2 again. So 4 minus 2 times 2 equals 0. Then we divide by 2 again, it's 1. 2 minus 2 times 1 equals 0. We stop here because it's smaller than 2. We cannot stop here because it's equal. It should be smaller than the divisor. So we have to go up. Our answer is, starting from where we stop at 1. Go up 0, 0, 0, 0, 1, base 2. Okay, so 1, 0, 0, 0, 0, 1. Now, how do we check this answer immediately to know whether it is correct or not? Okay, to check this, we start from 1. This is 1. Okay, this is 2, 4. Keep on multiplying by 2 because we have 2 here. This is 8. We have 16, and this is 32. Okay, so basically, starting from 2 to the 0, 2 raised to the power of 1 like this, and continue. Okay, so 2 raised to the power of 0 is 1, 2 raised to the power of 1 is 2, and then this is 4, 2 squared, 2 cubed is 8, 2 to the 4th, 16, and this is 32. It will keep on multiplying by 2. The next is 64, 128, 256, and so on. So we are just going to use the numbers with ones. Okay, zeros you are not going to include. So this is 32 plus 1 equals 33. Okay, so it's correct. So we add only 1 and 32 because we have ones there. These zeros we're not going to include in the addition process. Okay, so our answer is correct. 1, 0, 0, 0, 0, 1 base 2. Let's now proceed to section B. Here you're going to use a Venn diagram to show all the elements of the sets below. So we have 3 sets actually, and these are the values outside A, B, and C. Okay, so the first is to get all the intersections. Okay, so let's start with A intersection B. The common elements of A and B, 6 we don't have, 4, 3, 9 are common elements because we have 4, 3, 9 in both sets. So 4, 3, and 9. For A intersection C, we're going to look at A and C. 6 we have, 4, 3 we have. Okay, X9 we don't have. So that's it. For B intersection C, we're going to look at B and C. We don't have 0 in both. 9, no. 4, 3, 8, yes, we have. Okay, next is the intersection of all. A intersection B intersection C. To get this, you have to look at what are repeated here. So we have 4, 3, 4, 3, and 4, 3, or 3, 4. Okay, now let's delete all the values repeated. So here we're going to delete 4 and 3. The remaining is 9 because 4 and 3 are repeated. Here as well, the remaining is 6. Here the remaining is 8. Okay, so let's now have our diagram. Okay, so this is our set A, our set B, and our C. So let's start with A intersection B, that is 9. So it's here. Okay, this section is A intersection B. And we have 6A intersection C. That's the section. And 8 is B intersection C, this part. And 4 and 3, that's for 3 sets. It's gonna be here. 3 and 4. Okay. So 2 and 7 outside. Now let's look at our A. Our A contains 643x9. We have already 6439 because A is until here. So this section is A only. So we're going to put our X there. For our B, we have 09438. So we have to put our 0 here. That is B only because we have 9438 already. B is until here. Our C is 13468. We have already 6348. So 1 is here. That is C only. So this is our Venn diagram. Okay, showing all the elements of A, B, and C, and the elements outside the set. Okay, number 2, actually, here in a survey of 200 people, 90 speak Arabic and 130 speak Farsi, and 3 do not speak either. So that's why 3 is outside. Yes, because it's mentioned here 3 do not. So these people are outside the circles. Our A is, okay, people who speak Arabic, speaking Arabic, and our F, speaking Farsi, and we can use X as both. Okay, those people who both speak Arabic and Farsi. So let's put our X here. So this is Arabic only. This is 90 minus X. Okay, this section is Arabic only because you have 90 people who speak Arabic, and here is 130 minus X. This is Farsi only. So there are 200 people. Number of elements of universal set is 200. So 200 equals the first section, 90 minus X, plus both, plus 130 minus X plus 3. Okay, the universal set contains all the elements inside the box. So 200 equals, this is deleted, negative X plus X. This is 90 plus 130 plus 3, 223. The remaining is minus X. And then we're going to transfer X to the other side, 223 minus 200. Transfer 200 to the other side, X equals 23. These are the number of people who speak both Arabic and Farsi. Okay, so let's have our Arabic only. Arabic only is 90 minus x. So 90 minus 23 equals 67. For Farsi only, that's 130 minus x. 130 minus 23 equals 107. So the number of people who speak both, 23. Number of people who speak Arabic only is 67. And number of people who speak Farsi only is 107. Right? So that's it. You can check your answer by adding all 23. This is both plus Arabic only 67 plus 107 plus 3. These are the people outside equals 200. Okay. So it means that all our answers are correct. Now here you're going to find P, cross product Q, cross product R. This is about counting rule. Counting rule actually means we are identifying the number of all possible outcomes. Okay, all possible outcomes. Okay, so here there are two elements. Here we have two elements. Here we have three elements. Okay, this could be students here. This could be subjects, subject 1, subject 2, and this could be teacher 1, teacher 2, teacher 3. Okay, so when we have P, cross product Q, cross product of R, it's 2 times 2 times 3 equals 12 possible outcomes. So we're going to have 12 pairs. The first one is A, S1, K1 from left to right. Okay. Then we will have A, S1, K2, A, S1, K3. Then we're going to have A, S2, K1, A, S2, K2, A, S2, K3. Okay, so AS1 and then K1, AS1, K2, AS1, K3. Here we just changed our S1 to subject 2. Then K1, S2, K2, AS2, K3, and then use the B. This is A, second is B, student B, for example, then copy everything. S1, K1, B, S1, K2. Here B, S1, K3. B, S2, K1. B, S2, K2. And B, S2, K3. Okay. So we are just changing our A to B. This is A to B, A to B, A to B. Okay. So as you can see, we have 12 all in all, 12 pairs, 12 possible outcomes. Okay. That's the answer. The last one is BS2K3. Okay. Let's go to Q4. A patient is checked twice to identify whether an ailment exists or not. Let X be the number of observations that the patient has an ailment. An ailment is any sickness. Construct the discrete probability distribution of X and find the probability that at least one observation shows that the element exists. Okay, discrete probability means we can count the total number of possible outcomes. Okay, it has countable or finite number of possible outcomes. That's the meaning of discrete. Okay, here we can count, okay, twice. So during the first check, it could be true, okay? True here, T is ailment exist. You have to define that. Then F, ailment does not exist. So you have to define variables for you to save space. To save space, you need to define the variables. That's the purpose of that, saving space. So the first one could be true or false. This is during the first check. See, we are able to save space. If it was true during the first check, it could be true or false during the second. Here the same. If it was false in the first check, it could be true or false during the second check or checkup. Okay. Now we have the first line as true, true. Second is true, false. Follow the lines, FT and then FF. Here, TT means during the first checkup, it shows that the ailment exists, and during the second as well. Now, here, at least one. So that is the question. P, at least one is greater than or equal to 1, shows that the ailment exists. Okay, greater than or equal to 1 means at least 1. So the first is TT, second one is TF, third one is FT. Here we have 2, here we have 1, here we have 1T. So at least 1 is greater than or equal to 1. 2 T's, here 1, here 1. So there are 3 possibilities. 1, 2, 3. This, and this. Over 4, because we have 4 possible outcomes. 1, 2, 3, 4. So 0.75 equals 75%. Okay, so I hope that's clear. That's the answer to this question. Number 5. Okay, number 5, you're going to find the number of elements of this intersection, P intersection M. So we have 2 sets, P and M. So number of elements of P union M equals number of elements of P plus number of elements of M minus the both or intersection. This is M. Okay, so our number of elements of P union M is 350. Our P is 15. And number of elements of M is 405. This one is the required. So 350 minus 15 minus 405. Okay, so let's do it. It's better to transfer this to the other side. So we will not be wasting our time. If we transfer this to the other side, then it will be negative, and then we divide by negative. The same answer actually. But the easiest way is to transfer this to the other side. It will become positive. And this will be 15 plus 405 minus 350. So the number of elements of P intersection M is 420 minus 350 is 70. So the answer is 70. Okay, so that's it. Let's go to Q6. Here you're going to create a tree diagram using the scenarios below. So a robot makes watches. The robot may be okay or not, of course. Nowadays, most of the manufacturing companies employ or use robotics to produce products or manufacture products. One of these products is the watches, of course, or amongst these products are the watches. The watches may be defective or not. The watches are tested and may be approved or disapproved. So these are the given probabilities. So to create a tree diagram, we have to be very careful here. Okay, we're going to start with the first, which is 0.88. Okay. We have to draw our tree diagram. Okay, so let's start with P, robot is okay. That is 0.88. Is always binomial in this scenario, but in reality, it's not always binomial. Okay, here it's always binomial because we have only two, robot okay and not okay. But in reality, it can be trinomial or more. It can have 3 branches or more. So here we have only 2 branches. Okay, the first one and then the opposite. The opposite of robot is okay is robot is faulty. So this is 0.12 using complementation rule. Okay, that is 1 minus the opposite. So P not A equals 1 minus P of A. So here, not okay is faulty. So 1 minus 0.88 equals 0.12. Okay, that is using the complementation rule. The second part is here. Watch is okay, given that robot is okay. So we have 0.84, the given. The opposite is, of course, watch is defective or watch is not okay, 0.16. So 0.84 plus 0.16 is equal to 1 or 100%. Here, 0.88 times 0.12 is 1 or 100%. It's always equal to 1, even if you have many branches there. Okay, next is 0.69. That is, watch is okay, given that robot is faulty. So we have to continue here. Okay. So this is watch is okay is 0.69, given that robot is faulty. Okay, so before that, robot is faulty. Opposite is watch is defective, 0.31. That is 1 minus 0.69. Now let's proceed to 0.85. That is to approve watch, given that watch is okay. So here in the second stage, we have 2 watch is okay. This and the other one here, 0.69. Okay, so that is 0.85. We are going to approve the watch, given that watch is okay, it's high. Okay, and the opposite is reject or disapprove, 0.15. These branches we have to copy here below because it's given that watch is okay. Okay, so the same values, 0.85 and 0.15. The last one is we're going to approve, given that it is defective, it's very low, only 7%, because it is defective. Approve, okay, the opposite is reject, that is 0.93. This one is also defective, so we have to copy the branches there, 0.07 and 0.93. Okay, so now let's get the values of every line. The first line is this: robot is okay, watch is okay, and approve. Okay, multiply 0.88 and 0.84 and 0.85. The answer is 0.62832. So if the values are on the same line, you multiply. Here, 0.88 times 0.84 times 0.15. This is the value. Okay, so the same procedure for all. Okay, for this, next line, next line, next line, and the last line. So all in all, we have 8 possibilities. 1, 2, 3, 4, 5, 6, 7, 8. If you're going to add all of this, sum of all these probabilities, the answer should be 1 or 100%. If the total is not equal to 1, it means that something is wrong along the way here. So we have to double check all the values. Okay? So that is how to answer this particular question. Now we're going to answer these questions. There are 4 questions there. 3 are homework. Okay? So by the way, this scenario is an example of dependent events, because this depends on this and this depends on this. Okay? So let's start with the first question. Be approved. So getting approved. There are 4 possibilities there. This, 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 and this. Okay, approve is towards the end of the line. We can get the values immediately, okay, towards the end. So the first is 0.62832. Okay, second one is this, and this, and the last one is this. Adding all the values, 4 values, that is 0.71116. Multiply this by 100, the answer is 71.116%. That is approved. Okay, the next one is P, watch defective. What is the probability that the watch is gonna be defective? There are 2 possibilities there, this and this. Well, we don't have watch defective without the robot, right? So we have to multiply 0.88 and 0.16 for the first one. And the second one, we have to multiply 0.12 and 0.31. And other values, that's 0.178 times 17.8%. Okay, now letter C is P, watch defective and approve. Please take note that P, watch defective and approve is equal to P, approve, and watch defective. There is no difference there. We can change the order of these 2. Okay, so let's proceed to the answer of this. Watch defective and approve. There are 2 possibilities. This, approve is towards the end, so we can get the value. Okay, and this one. So there are only 2 possibilities there. Watch defective and approve. So that is 0.009856. And the second one, 0.002604. So this is the value times 101.246%. Okay, let's now proceed to letter D. The probability that is going to be approved given that watch is defective. So we're going to use this formula, P of A given that B equals P of A intersection B, or and, then the second one will come down. Okay, so let's use this formula. So our A is this, approved, and this is our B. So basically, we are not going to change our A and B to the given scenario. Okay, so A and B here could be any two events. In this example, in D, the first event is approved. This is the second event, watch defective. Okay, so this is what we call as conditional probability. Because there is a condition given that B has occurred already. Okay, so we change. This is our given that, this line. Given that will become intersection or and. And the second one will come down. So what's defective will come down. So we have already the values, P approved, okay? And what's defective is here, C. The answer here was 0.01246. And what's defective, the answer here was 0.178. A while ago, I showed the answers of both. Okay, so we divide these values. You can rewind this recording and check these values again. The answer is 0.07 or 7%. So C is correct here. Approved given that watch is defective is 0.07 or 7%. Okay, so it is indeed correct. I want you to solve this during your free time. Letter E, F, and G. You know already how to answer using the examples I gave here, A, B, C, and D. All right, so that's it. Let's have number 7. Here, we have 4 questions. So let's read our problem. A veterinarian or vet, this is animal doctor of animals, okay, has identified that the probability of detecting a virus is 90%. A virus in a horse. Okay, so we define our variables. D is detecting the virus and not D. This is not D or D prime, D complement. Not detecting the virus, and we have S as success rate and F as failure, because we talk about failure here and success. Okay, so let's answer letter A, B, C, and D using a tree diagram. So the first 2 branches will be about detecting the virus. It's given already here 90%. So the opposite will be 10% because we have 100% minus 90% using the complementation rule. Okay. Here, if the virus is detected, he's going to proceed with the first operation, which has a failure rate of 21%. So we'll continue here, not here, because it's mentioned if the virus is detected. So we'll continue on this line. We have 79% as the success rate because the failure rate is 21%. 100 minus 21 is 79. So that is for the first operation. Now, if the first operation is not successful, that means failure. We continue here, right? We are not going to continue here because this is for success. So if the first operation is not successful, which means failure, it's going to proceed with the second operation. The success rate is 20%, so the failure rate is 80%. Okay, so that completes our tree diagram. We call this a tree diagram because we have branches. So let's answer A. A is not detecting the virus. This is, of course, 10%, this one. The second one, P horse is cured. Cured means success in the first operation. So this one. Remember that we cannot go to the first operation without detecting first. So we multiply 90% and 79%. 90% is 0.9 or 0.90 and 79% 0.79. So that is 71.1%. Okay. Let's proceed now to the next question. Okay. Letter A is 10% and B is 71.1%. Let us see what is the probability that the horse can be cured. It means success. So there are two possibilities, this and this. Success in the first and success in the second. The first one we already calculated, that is 0.711. For the second possibility, that's 90% detect failure in the first and succeed in the second operation. So we multiply 0.90 or 90%, 0.21, that's 21%, and 20%, 0.20, that is 0.0378, and add these two. Okay, so the value is 0.7488, or that is 74.88%. So the first one is 10%. This is 71.1%. This is 74.88%. You multiply these three, and the answer we add to the first one. Okay, so the last letter D is using complementation rule. Question is, what is the probability that the horse cannot be cured? So we have the cured already here, 74.88%. So P horse not cured is the opposite. So 1 minus P cured, 1 minus 0.7488 is the opposite. So that is 25.12%. 0.2512 times 100. You can also get this using the diagram. Horse not cured is failure. Okay, so there are two possibilities there. This, the DFF, and not detecting the virus. Okay, so P not cured, the horse is not cured, is 0.9 times 0.21 times 0.8 plus 0.10 or 0.1. Okay, this is for failure. 90%, 21%, 80%, plus, of course, this is also part of the failure when you're not able to detect the virus. So the answer is 0.2512, which is equal here, 25.12%. Okay, so that's it. Okay, number 8, if two dice are rolled, calculate the following. D of D1 is equal to 4, D1 plus D2 is greater than or equal to 9. We have here given that. So this is an example of conditional probability. Okay, so we know that for die 1, we have 6 possible outcomes, right? And same with D2. 1, 2, 3, 4, 5, 6. Because we have 6 sides. So we can have our die 1 here. 1, 2, 3, 4, 5, 6. And here we can have our die 2. This is plus. This is die 2 or D2. Then you add 1 plus 1 is 2. 1 plus 2. 1 plus 3. 1 plus 4. 1 plus 5. 1 plus 6. This is 2 plus 1. 3. 4, 5, 6, 7, 8. This is from 3 plus 1. 4, 5, 6, 7, 8, 9. So this is for our die 1. This is for die 2. This is 4 plus 1, 5, 6, 7, 8, 9, 10. This is 5 plus 1, 6, 7, 8, 9, 10, 11. From 6 plus 1, 7, 8, 9, 10, 11, 12. So the highest sum is 12. 6 plus 6, the lowest sum is 2, 1 plus 1. Now, this is using the conditional. A intersection B over P of B. Our A is D1 equals 4. Given that our B is D1 plus D2 greater than equal to 9. Okay, so this is P of D1 equals 4 and, okay, or intersection D1 plus D2 greater than equal to 9, and down is D1 plus D2 greater than equal to 9. So we change our line to and or intersection, and this second one will come down. So let's find our die 1 or D1 equals 4. It's here. And let's draw a line. Find the numbers there greater than equal to 9. These are the numbers. There are 2. So the answer is 2 over. Then count all the numbers satisfying this greater than equal to 9 in this sums here. So we have 1, 2, 3, 4, 5, okay, 6, 7, 8, 9, 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. That's D1 plus D2 is greater than or equal to 9. So we count from 9 until 12. So we have the 2 here is on this line. D1 equals 4. We have 5, 6, 7, 8, 9, 10. There are 2 numbers there. And 10 is in all these sums. Okay, how many are from 9 until 12? There are 10, so 0.2 equals 20%. All right, so that's all for the written part of your midterm exams. Thank you so much for watching. Until the next time, bye-bye.